Welcome to solverfy.
We're going to first define our decision values. I'm going to let x sub I times j be our number of caskets shipped, where I is equal to our distribution site, and j in this case is going to be our 3 plants, either Chicago, Dallas, or Atlanta. We're going to have 6 different variables. We're going to have x of c sub t. We're going to have x of dt. We're going to have x sub at. We're going to have x sub cta. We are going to have x sub dta. And we are going to have x sub ata for our 6 different decisions. Now, for our objective function, we can write this as 75 x sub ct plus 95 x cta plus 50 x dt plus 70 x dta plus, so again I'm just taking my profits for each, 82 sub xat plus 98 sub xat. Then this is our objective function that we want to maximize. Then we have some constraints. For our plant capacity constraint, we're going to have that x sub t plus x sub cta has to be less than or equal to 3,500. We also are going to have that x dt plus x dta has to be less than or equal to 3,200. And we are going to have that xat plus xata has to be less than or equal to 3,700. For our demand constraints, we're going to have that xct plus xdt plus xat has to be greater than or equal to 4,000, and xcta plus xdta plus xata has to be greater than or equal to 2,500. We also are going to have our non-negativity constraints. Since none of these can be negative, they all have to be greater than or equal to 0. Then we can implement this into our programming model in Excel, and we're going to find that our optimal shipping quantity from Atlanta to Trenton is going to be $1,300.